before the age of towering dinosaurs ended, before forests learned how to burn, before the oceans belonged to anything we would recognize today. There was something heavier than them all. Not taller, not longer, but more massive. So heavy that if it existed on land, it would collapse under its own weight. So dense that even the ocean itself had to work to keep it alive. This was not a predator chasing prey across open plains. This was not a reptile ruling the skies. This was a creature built for pressure, for silence, for a world where size did not mean speed, but survival. Picture the Earth roughly 40 million years ago during the Eocene epoch. The planet is warmer than today. No polar ice caps. Sea levels are higher. Shallow tropical oceans flood vast continental shelves. The seas are rich, crowded with early sharks, giant turtles, and the first fully aquatic whales. But beneath the surface, something very different is taking shape. Not streamlined, not fast, not elegant, something unnaturally heavy. In 2010, in the deserts of southern Peru, paleontologists began uncovering fossilized bones embedded in ancient seabed rock. At first, the fragments were confusing. Ribs unlike any whale on record, vertebrae so thick and compact they felt closer to stone than bone. Each piece was astonishingly dense, far denser than the skeletons of modern whales. When the remains were finally analyzed, the implication was disturbing. This animal did not rely on buoyancy. It fought against it. The creature would later be named Perucetus colossus, and its estimated mass forced scientists to reconsider something fundamental. What does it mean to be the largest animal ever to exist? Dinosaurs dominate our imagination because of height and length. Argentinosaurus, Patagotitan, land animals stretching over 30 meters long. But mass tells a different story. Preliminary reconstructions suggest Perucetus colossus may have weighed between 85 and 340 metric tons. Even the blue whale, the heaviest animal alive today, averages around 150 to 180 tons. Perucetus may have matched it or exceeded it, not through size alone, but through density. Unlike modern whales, whose skeletons are relatively light to aid swimming, Perucetus evolved osteosclerosis, a condition where bones become abnormally thick and heavy. Its ribs were swollen, its vertebrae compacted, every bone reinforced, as if gravity itself were an enemy. Why would evolution do this? Because this animal was not built to roam the open ocean. It was built to sink. One leading theory suggests Perucetus lived in shallow coastal waters, much like modern manatees or dugongs, but taken to a biological extreme. Instead of chasing prey, it likely moved slowly along the seafloor. Neutral buoyancy was not enough. It needed ballast. Its own skeleton acted as an anchor, allowing it to stay submerged without constant effort. But this came at a cost. A body this massive cannot move quickly. It can't escape danger. It cannot migrate long distances. Every evolutionary advantage created a vulnerability. And yet, Perucetus survived, which means the environment it lived in was stable enough and rich enough to support a creature of impossible weight. This raises an unsettling question. If the oceans once supported animals heavier than any dinosaur, what else did they support? Because Perucetus did not exist in isolation. It lived during a time when marine ecosystems were undergoing radical change, when early whales were experimenting with new forms, new niches, new extremes. Some became fast, some became deep divers, and at least one became immovable. Evolution was not refining a perfect design, it was testing limits. There is something deeply unnatural about an animal that grows heavier than its environment wants it to be. Water is meant to lift. Perucetus resisted. Land animals must fight gravity. This creature embraced it. Its body suggests a life spent near the bottom, where light fades, sound travels differently, and pressure never relents. A place where size does not intimidate, it endures. And here is where the mystery deepens. The fossil record we have is incomplete. No skull has been found, no tail fluke, only fragments, dense, silent evidence of something enormous, which means we do not yet know how it fed, how it reproduced, how it defended itself, or what happened when an animal that heavy finally died. because when a creature of that mass collapses into the seafloor, it does not disappear. It changes the environment around it, and what may have gathered in the shadow of its body is a story far stranger than size alone. When an animal of that magnitude dies, it does not simply vanish, it becomes an event. In modern oceans, the fall of a large whale to the seafloor is known as a whale fall, a sudden transfer of vast amounts of energy into the deep. Entire ecosystems ignite around it. Scavengers arrive first, then specialists, then organisms that exist nowhere else. Now imagine that process multiplied, because Perucetus colossus was not just large, it was unnaturally dense. When it sank, it would not have drifted. It would have descended slowly, deliberately, until it met the bottom with the full force of its mass, and there it would remain for decades, perhaps centuries, a single body becoming a long-term foundation for life. This reframes the animal entirely. Perucetus was not just a consumer within its ecosystem, it may have been an architect of it. Its immense skeleton, packed with lipids, minerals, and organic matter, could have sustained deep-sea communities far beyond its own lifetime. In this sense, size was not about dominance, it was about persistence. But how does evolution produce something so extreme? To understand that, we have to return to the Eocene oceans themselves. This was a world without ice caps. Ocean circulation was different. Coastal seas were warm, shallow, and chemically rich. Primary productivity was high. Food webs were dense and layered. In such an environment, speed is not always rewarded. Efficiency is. Perucetus belongs to a group known as basal cetaceans, early whales that had only recently abandoned land. They were still experimenting. Some retained functional hind limbs, others refined echolocation, and some, like Perucetus, moved in the opposite direction of modern whales. Instead of becoming lighter and faster, they became heavier. One leading hypothesis suggests Perucetus fed on slow-moving or bottom-dwelling organisms, perhaps large invertebrates, benthic prey, or nutrient-rich plant material. This kind of feeding does not require pursuit. It requires stability, and weight provides that. But extreme weight introduces severe biological constraints. A body this massive needs enormous energy input. Its metabolism must be finely balanced. Too little food, and collapse is inevitable. This tells us something crucial. The oceans that supported Perucetus were not fragile. They were abundant, stable enough to sustain an animal that could not flee famine or disaster, which means when those conditions changed, Perucetus had nowhere to go. By the late Eocene, global climates began to cool. Ocean chemistry shifted, sea levels fluctuated. The shallow, warm coastal environments that favored extreme density began to shrink. For lighter, more mobile whales, adaptation was possible. For Perucetus, adaptation meant losing the very trait that defined it, and evolution does not always negotiate. Sometimes it simply ends an experiment. What makes Perucetus unsettling is not just its size, it is what that size represents. A moment in Earth's history when biological limits were pushed in directions that now seem impossible. Today, the largest animals survive by being light for their size. Streamlined, buoyant, efficient, Perucetus chose the opposite path. It grew heavier than the ocean wanted it to be, and for a time, the ocean allowed it. We often ask what the biggest animal ever was, but that question misses something deeper, because Perucetus was not trying to be the biggest. It was trying to be unmovable, a living mass tuned to pressure, gravity, and stillness, something closer to geology than biology. And perhaps that is the most unsettling thought of all, that Earth once produced creatures so extreme that they blur the line between animal and environment. Not rulers of their world, not conquerors, but monuments, alive, and buried now beneath layers of time, waiting for us to realize that largest does not always mean what we think it does.